This is part 2 of section 1.3. You need to also be aware of a bunch of identities that are used frequently in calculus. For example, as we said, cosecant of theta is the reciprocal of sine, and secant of theta is the reciprocal of cosine, and cotangent theta is the reciprocal of tangent. But you should also know that tangent is also equal to sine theta over cosine theta. That's a pretty helpful one. You also need to be fluent in the fact that sine squared theta plus cosine squared theta is 1. Secant squared theta equals 1 plus tangent squared theta. Cosecant squared theta equals 1 plus cotangent squared theta. There are times when you need to know the half angle formulas in calculus, the sum identity addition formulas, the difference identity subtraction formulas, and the double angle formulas. So please make sure that you take time to review these formulas, and if you think that you need help with them, so if you need further assistance on those, go to www.khanacademy.org and you can type in any of those topics and they will give you some sample problems to try. They will also have there examples of law of sines and law of cosines. Let's do some examples of solving using trig identities. For example, if I have sine squared theta equals 3/4, I know that if I'm trying to solve for theta, I need to square root both sides in order to get sine by itself. So I would start off with doing square root on both sides of the equation, which would give you square root of 3 over 2 when you square root that fraction. And then I know that sine of theta is equal to square root of 3 over 2. Let's see what we're talking about. Where we're talking about a 30, 60, 90 triangle, because the relationship is 1 square root of 3, 2 between the sides. And so the theta would currently be located in the largest angle, other than the 90-degree angle, because it's square root of 3 is bigger than 1. So therefore, theta would need to be the same as a 60-degree angle. 60-degree angles are otherwise known as pi over 3 in radians. They want to know all of the angles that are available between 0 and 2 pi. So I know that sine is positive in quadrant 1. I also know that sine is positive in quadrant 2. So if I put that reference angle in quadrant 2, it means that theta could also be 2 pi over 3, because that would be the angle that's in quadrant 2. Let's do another example. In this next case, I would need to have the trig functions to be the same. So I would replace my cosine squared theta with 1 minus sine squared theta. I can then collect the sine squared thetas on the same side of the equals by adding sine squared theta, thus making 2 of them over there. I can divide both sides by 2 and square root both sides. So now I need to think about what angle makes square root of 2 over 2 for sine, and I know I'm talking about a 45-degree triangle. 45 degrees would be pi over 4 radians. So where would theta be pi over 4? Let's see. Well, for sine squared to equal cosine squared, they would both had to be positive actually, because it's a square, they could be positive or negative. So basically, I'd be talking about a pi over 4 in quadrant 1. I could talk about pi over 4 in quadrant 2. So that's going to be 3 pi over 4. I can talk about a pi over 4 in quadrant 3. So that would be 5 pi over 4. And I can talk about pi over 4 in quadrant 4. And that would be 7 pi over 4. And again, it's because both sides are being squared when we originally start this problem that we know that we can have the square basically cancels out the negative, because a negative times negative makes positive. One more example. In this next case, we have a double angle going on in the same problem that we have a single angle going on. So we would need to go ahead and change sine to theta to use one of the double angle formulas. And I know that sine 2 theta is the same thing as 2 cosine theta sine theta. I can now go ahead and use some algebra 2 skills and factor out a cosine theta. So now I have two equations. Where is cosine theta equals 0? And where is 2 sine theta minus 1 equals 0? Well, I know that cosine theta equals 0 when theta is 90 degrees and also 270 degrees. So where is 2 sine theta equal 1? Where is sine theta equal a half? I know that sine theta equals a half when theta is a 30-degree angle. That is pi over 6. It also occurs again in quadrant 2. That sign would be positive. So if you put a reference angle of pi over 6 into quadrant 2, you are now at 5 pi over 6. Now for the last of the notes for the week. We're talking about graphing trig functions, cosine, sine, tangent, secant, cosecant, and cotangent. So these are the basic parent functions of the trig functions. And so some things that you need to know about this. First of all, sine theta and cosine theta have a period of 2 pi. It means that they start and they end in 2 pi. They repeat after 2 pi. So if you look above, you can see this is the period we're talking about in here. They're periodic functions. So if I were to change this so that it would be sine 2 theta, what that's going to do is it's going to cut the period in half, because this is saying that you have 2 sine functions where there used to be 1. So what we're going to do to figure out the period is we're going to take 2 pi, because that's the normal period. We're going to divide it by 2, because that's what's in front of the theta, and so the answer is now pi. We've cut the period in half. If we were to have cosine a half theta, again, I would take 2 pi, because that's the normal period. I would divide it by a half, which means that I'm going to multiply by 2, and that means that now my new period is 4 pi. As we've talked about before, this is a horizontal stretch, which is what's happening when you're changing your period. Whereas this is a horizontal shrink, because it's a 2 and not a fraction smaller than 1. You can also have the typical reflections. For example, that would be a reflection around the x-axis. Whereas this would be a reflection around the y-axis. Also, please keep in mind that if I were to take a cosine function and add something to it, that would be a translation up. Or if it was a -3, it would be a translation down. Also keep in mind, if I were to say I wanted to do theta plus, say, pi over 3, that would mean that my entire cosine function would be translating to the left pi over 3. Or if it was minus pi over 3, it would translate to the right pi over 3. So these are the same translations and reflections that we talked about in the last unit, except we're doing them with sines and cosines. Again, if you have any questions on graphing trig functions, please visit Khan Academy to find out solutions to your issues.